Hi, welcome to Concept Based. I'm John Hepworth, and today's topic is out of the Year 11 Advanced Probability and Data section of the syllabus. We're going into the Conditional Probability section, which I definitely find students that I teach can be confused by this section. They've done probability in Year 9 and 10, and it seems pretty straightforward. And then they get to this little bit where it's a little bit different. It's conditional, and there's a new formula that pops up. So we really want to have a look at this and try and work out what the best way is to attack these types of conditional probability questions. Up front, however, I just want to read the dot point from the syllabus just to make it clear that there is one restriction on these types of questions. It says, examine conditional probability by restricting the sample space and event spaces in a Venn diagram using a two-way table, a tree diagram, and other arrays. So it doesn't want you to just examine the conditional probability straight up. It wants you to do it based on Venn diagrams using two-way tables, arrays, and so forth like that. And I want to show you why this pretty much has to happen, because there's information that we don't have if we don't use Venn diagrams. In the 2020 HSC, there was a question just like this one, and part one of the question required students to draw a Venn diagram, and then part two asked the conditional probability question. Now, if you struggle with drawing Venn diagrams and working out that little bit in the middle of them, then you really are going to struggle to do this conditional probability question, even if you're completely fine with using the formula. Now, the good thing about the formula is that it is on your reference sheet. So the upcoming 2024 Advanced Mathematics HSC reference sheet has this section in probability. And the third formula just there is the one that we're talking about. That's our conditional probability equation. And it says here the probability of A given B. That's what that A pipe B means. The probability of A given B equals the probability of A and B over the probability of B, where the probability of B cannot equal to 0, of course, because if we had 0 on the bottom of our fraction, we can prove that 1 equals 2. All mathematics falls apart. So the probability of B can't be 0. Okay, so if we were to go and apply this straight formula to the question that I have here, I'm going to demonstrate why essentially it doesn't work, or we just don't have enough information to solve it. So let's go and do that first of all. So of 30 students, 20 study history, 12 study geography, and 8 study neither. A student is chosen at random. Given that, now that's a huge part of conditional probability. You're going to be, there's going to be words in the question that say things like this, given that something happens, what's the chance of something else? That's what conditional probability is all about. So given that they study geography, what is the probability that they do not study history? Okay, let's translate this question into the formula and see where it falls down. So we're saying the probability of them not studying history, so that's history hat, not history, given that they study geography. Now, if we just use the formula, this would be the probability of not studying history and geography over the probability of studying geography. Now, this bottom part of this fraction is easy. We can work out the probability of them studying geography because out of 30 students, 12 of them study geography. So the probability is just 12 out of 30. What's the problem is this bit on the top. What's the probability of not studying history and studying geography? Now, you could fall into a trap here, and students do. They could say, well, 20 students study history, so the probability of them not studying history is, well, that's 10 students. And then 12 of them study geography, so they have to then consider, well, what amount of those students that are not studying history are studying geography? And that's just completely unknown if we just try and decide, well, we don't know which students are crossing over and which students aren't crossing over. So they get stuck on this part of the fraction straight away. And they're like, this formula doesn't work. And they try and put in amounts that just seem right. Like, well, there's 10 of them that don't study history. So there's 10 of them out of 30. There's 12 of them that do study geography. And so they start using numbers like 2 straight away or 10 straight away, or they don't know, okay? So we can't do that. What we want to do is we want to go ahead and draw a Venn diagram first. So let's draw up our Venn diagram where we are studying history and we are studying geography. And don't forget there is neither, so there are some students outside of this Venn diagram. And the way that I fill in Venn diagrams really quickly is I just fill the numbers into their own areas first of all. So 20 study history, 12 study geography, and it says that 8 study neither. And what I then do is I just go and see how many students I've created. And if we do 20 plus 12 plus 8, we end up with 40 students. And there isn't 40 students. There's only 30 students. So how did we get these extra 10 students? Well, those extra 10 students are the 10 students that are studying both. So if we put these 10 students in the middle, now we've got a bigger problem. Now history is more than 20, so we need to remove 10 out of just studying history and have only 10 of them. And our geography is not 12 anymore, so we remove 10 and we have 2. Now in just the history section, there's 20 students. In just the geography section, there's 12 students. And so now if we add it all up, 10 plus 10 is 20, plus 2 is 22, plus 8 is 30 students. So it's critical to be able to draw these Venn diagrams accurately and knowing how to put those students in the combined section and remove them from the other section so that it is weighted correctly. And so that method that I just showed you then, I would recommend every single time in building those Venn diagrams. Now that we've built this Venn diagram, the ability to fill in our formula for conditional probability becomes far easier. So if we now go back to what we wanted, which was the probability of not history given they're in geography is the probability of not history and geography over the probability of geography. Now, as before, we still already know our geography part. So the probability of studying geography is 12 out of 30. So now what we need to look for is this bit, this probability of not studying history and studying geography. So students that don't study history are here, and the ones of those that study geography are just there. So there is just 2 students that don't study history and they do study geography. So that is our 2 out of 30 students. And so now we have got the probability of not history and geography over the probability of geography. And you end up always getting in a situation where you're cancelling down. So we cancel the 30 off the top and the bottom, and we end up with 2 over 12, which we have to simplify. Otherwise, we would feel very uncomfortable indeed. And we end up with a probability of 1 in 6. Now, some of you may see that happen and go, well, why not just get that straight off the diagram? Okay, so what does that actually mean, being able to do that? So let's consider what's being asked. What is the probability of a student not studying history given they study geography? So what does given they study geography mean? Well, given they study geography, we are now locked in to this part of our Venn diagram. And this part of our Venn diagram only has 12 students in it, 10 that study both and 2 that only study geography. And so therefore, the chance of them not studying history in this section of the Venn diagram is just the 2 of them out of the total of the 12 of them. So we can get the 2 out of 12 straight away without using the formula. So why would we use the formula? Well, you can be given questions where you are given the probability of things like not history and geography. So you do need to know how to substitute into the formula correctly, because it could be asked in a different way. But we can literally look straight at the Venn diagram and go, well, what is the size of the sample we're talking about? 12 of them. And what's the part that we're actually after? In this case, 2 of them. And therefore, we can get the 2 out of 12 straight away. So what are the takeaways from this lesson? Conditional probability does require you to be able to do Venn diagrams, two-way tables, arrays, tree diagrams. Make sure that you've got that stuff down pat before you start attacking conditional probability, because you won't be able to do it without that skill set. 2, we definitely want to be able to do both visual understanding of what our answer should be and formula understanding of what our answer should be. As I always say here on concept based, draw a picture. You know, if we get to an answer and our first time we got to our answer when we got to 1/6 or 2/12, how would we even know if this makes sense unless we could actually go and look at a picture and go, yeah, okay, that's in the right ballpark and that does make sense. So it's a real combination of skills that are happening in this one. Just because your formula is on the formula sheet, as I showed you, doesn't mean that, oh, I don't need to study conditional probability. The formula's right there. I'll just plug it in. You can't just plug it in. You need to find the information by using a Venn diagram.